Okay, today we're doing 2-3, solving multi-step equations. So when we were solving our equations last time, you learned to make sure you isolated the variable term, and then you isolate the variable. Well, now we have one more step. We're going to simplify first. So if we look at our problem, 13 is equal to 5 plus 3b minus 13. If I look at this on the right-hand side, I have 5 and minus 13. Those are like terms. They're both numbers, so I can simplify them. 5 minus 13 is negative 8. So now I've simplified. I can't add any other like terms. So now I want to isolate the variable term. So again, I put a little box around it, leaving it alone. I want to now get rid of the minus 8. So the inverse operation is add 8. Add 8. So now these cancel. 8 minus 8 is 0. I just have 3b on the right-hand side, 21 on the left. So now I isolate the variable. So I have to get rid of the 3. 3 times b. Inverse is division. Divide both sides by 3. 3's cancel. I have 1b. 21 divided by 3 is 7. So now 7 is equal to b, same as b equals 7. And we solved our first multi-step equation. So on the second one, again, I want to simplify first. So I have 7p plus 8p minus 12 equals 59. 7p plus 8p, I can add those together, which is 15p. Bring down the minus 12 equals 59. So now I want to isolate the variable term. So the 15p I'm leaving alone. That means I have to get rid of the minus 12. So the inverse operation, plus 12. Again, we have to do it both sides of the equal sign. 12 minus 12 is 0. On the left, I have 15p. 59 plus 12, 11, 671. So now I have 15p equals 71. I isolate the variable, which is just the p, so I have to get rid of the 15. Divide both sides by 15. Now 1p equals 71/15. 15 does not go evenly into 71, but I know 15 times 4 is 60, and that leaves me with 11 left. So I can write, sorry about that, p equals 4 and 11/15, and then that problem is done. You could write it as a decimal. I have a feeling in the homework when you get to it that the book will go ahead and write it as a fraction. So that's the way you'd want to simplify it. Okay, so another example. This one, I have a negative 2 outside of my parentheses, 3x plus 9 inside the parentheses equals 24. So I learned and we reviewed distributive property, that this number on the outside, negative 2, gets multiplied by every term inside. Negative 2 times 3x is negative 6x. Negative 2 times positive 9 is negative 18. So we get negative 6x minus 18 equals 24. So now we start going through our steps. I have simplified. Now I have to isolate the variable term. So the negative 6x I'm leaving alone. The negative 18 I want to cancel. Inverse operation. Positive 18. Again, these always have to be the opposite signs. If it's a negative, you need a positive. If it's positive, you need a negative. If it's multiplication, you need division. Division, you need multiplication. So now the 18s will cancel, and I have negative 6x equals 4 plus 8 is 12. So I carry the 1, 2, 3, 4, so it's 42. So negative 6x equals 42. I have my variable term of x, it's multiplied by the negative 6, so now I have to divide by negative 6. So negative 6 over negative 6 is positive 1x. 42 divided by negative 6 is negative 7. So now I get x equals negative 7. And that problem is solved. Another type of problem you'll see will have fractions in it. So there's two different ways to solve fraction problems. So I'm going to show you how to use common denominators, and then later how to eliminate the denominators if you don't like fractions. But fractions are our friends, so sometimes we want to keep them. Alright, so problem 4 says 2m divided by 7 plus 3m divided by 14 equals 1. I have 7 and 14. Well, 7 times 2 is 14, so my common denominator is 14, so I have to multiply by 2 over 2. So we always, with a fraction, want to multiply by 1. The same number over itself is 1. So 2 times 2m would be 4m over 14. So I now get 4m over 14, or divided by 14, plus 3m divided by 14 equals 1. Since they have common denominators, I can add the numerator, 4m plus 3m, which is 7m over 14 equals 1. And now I want to get my variable term by itself. I want to isolate it, so I get rid of division with multiplication. So I'm dividing both sides by 14. So 14 over 14 leaves me with 7m. 14 times 1 is just 14. And now I want to isolate the variable. 7 times m equals 14. Divide by 7. So now 7 over 7 is 1m. 14 divided by 7 is 2. So m equals 2. And we have solved that problem. So not always will they have fractions. Sometimes they will have decimals. So this is how we could solve it, leaving the decimals in there. But we can also eliminate all the decimals. So as you look across problem 5, we have 1.2, or 1 and 2/10 equals 2 and 4/10 minus 6/10 x. So as I read it, each one is a tenth. You always want to use the smallest fraction, because 2/10 is 2 over 10. So your common denominator, if there had been a 0.06 or 6/100, that would have been the smallest, so you'd want to move your decimals 2 places by multiplying by 100. But in this case, I just need to move it 1 place in each one, which means I'm going to multiply everything in this whole equation by 10. So 10 times 1.2 is 12. 10 times 2.4 is 24. 10 times 6.6 is 6. So I get 12 equals 24 minus 6x. And so I've simplified the decimals, and now I want to start solving. So I isolate my variable term. It is negative 6x, or minus 6x. So I have to get rid of a positive 24, so I subtract 24, subtract 24. 24 minus 24 is 0, so on the right side I have minus 6x. 12 minus 24 is negative 12, so I bring down negative 12 equals negative 6x. Again, I'm interchanging minus and negative. They're the same thing. They're going the same direction on the number line. So now I need to isolate this variable term. Again, there is no sign between, so it's a division that we need to do as their inverse, because we had -6 times x, so we do the inverse, divide by -6. So -6 over -6 is 1x. -12 divided by -6 is +2. So 2 equals x, or x equals 2. Either way, we can write it. So on that one, we eliminated our decimals. So we're going to do a fraction problem where we're going to eliminate our fraction. Okay, so now it's working again. Problem 6. -2/9 x minus 4 equals 7/18. So I have denominator of 9 and 18. So common denominator is 18. So I want to multiply every single term in this problem by 18. So when I do that, I already wrote it out, 18 times the -2/9 x minus 4 times 18. The 7/18 gets multiplied by 18. So 18 divided by 9 is 2. 2 times -2 would be -4x. 4 times 18, 4 times 8 is 32. So 40 plus the 32 is 72. It was in negative, so I need to make sure I bring that down. 18 divided by 18 is just the 7, because 1 times 7 is 7. So now my equation has no fractions. It looks just like all the other two-step equations we did the other day, so now we can solve it. So if you don't want to leave fractions in your problem, you can eliminate them. So now I isolate my variable term, minus, do the opposite, plus 72 plus 72, and now on the left side I have -4x, on the right side I have 79. Isolate the variable term, divide both sides by -4, -4, 4 goes into 7, 1 whole time, that remains 39, 4 times 9 is 36, so that goes in negative, because we have one negative sign, my answer is going to be negative. When you have the two negative signs, your answer is positive. So, again, the 4 went in there once, and then that left me a remainder of 39. 4 goes into 39 9 times, which is 36. So that left me with 19, 36, and the 39 have a difference of 3, and I put it back over 4, -19/34. And now my multi-step equations are finished, and you can start the homework.